everybody's got this part, right? If you do inverse, it just flips everything. So that's going to flip, that's going to flip, that's going to flip, that's going to flip. It's going to be symmetrical about this line. Listen up, please. Symmetrical about the y equals x line. All right, next part. When we do inverse, this is the symbol right here for inverse. It's that little -1 thing, and it doesn't really mean a power of -1. It doesn't mean a power, it just means that symbol represents. The symbol represents the inverse. And I'm going to show you how to do the inverse of a problem. So if you have f and you want to do the inverse, it's going to be read f of -1. And the inverse functions, then f of a equals b if and only if f of -1, in other words, the inverse of b equals a. So if you plug 1 into 1, that's why we get the composition stuff. If you plug one thing into one formula, and then you re-plug it back in the other way, they both should give you the same answer. For example, if I took one function like this one, and I did f of 5, look what happens when I do f of 5. 5 plus 2 gives me 7, right? You see that? F of 5 gives me 7. Now, watch what happens when I take the inverse problem and plug in a 7. So f inverse of 7, what is 7 minus 2? 5. So when we do, if you do one function, ladies, when you plug in one number to one function, it gives you an answer, and you plug that answer into the inverse problem, it'll take you back where you started from. That's what inverse does. It takes you, it's like going in reverse order. Any of you guys ever do those problems where they had this big story problem, and it said, little Sammy had a number, he took 5 away from that number, then he multiplied it by 3, then he said 1/4 of that number, and he got all the way down, blah, 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 all the way to the very end, and it said, what was his number? And you ended up with this big number at the bottom. You had to like go backwards, like you had to start with that number and do, if the last thing you did was multiply, then you divide, and the thing you did before that was add, so you subtract, and the thing before that was like fraction, so you do the reciprocal, and you work your way all the way back to the front in reverse order, and it tells you what your number was. Did you guys ever do that? I'll have to give you one of those story problems where you have to like big story problem, you get to the very end, so you have to work your way back. You get the final number, and you just like undo it all the way back till you get to the very front. Yeah.
No, what you need to do is you need to take a huge, long algebraic equation.
This is what you're going to do to make it inverse. So watch this very carefully. It's actually not really tricky, but it's kind of, look at this. 3 steps. You can do this in 3 steps. You're going to change the f of x to y. So wherever you find an f of x, you're just going to change it back to y. Then you're going to replace x with y and y with x. So you're going to switch places with them. In this case right up here, I would say y equals x plus 6 over 2 is going to turn into x equals y plus 6 over 2. So see, all I did is I just changed the f of x to y, then I switched places with them, and then I solved for y. The last thing you do is solve for y. Would you guys all know how to solve this part right here for y? How do I get rid of a 2 off the bottom? Well, if I need to get rid of that 2, I just multiply both sides by 2, right? So if I do that, right, if I multiply all of this by 2 and multiply this x by 2, I end up with 2x equals y plus 6. Right? Y plus 6. And then to get y by itself, all you have to do is minus 6 from both sides. Now, since you can't put a 2x with a 6, you just have to write it 2x minus 6 equals y, which is the same thing as y equals 2x minus 6. If I just flip it all, just flip the whole thing over. So I just flip the y on one side and 2x on the other. That way it reads y equals 2x minus 6. It's the same thing. These two things are the same. Okay? Now watch what happens if I graph these functions. If I were to graph both of these functions, like this one right here, remember we talked about the common denominator thing? So if I split this into a common denominator, this is going to have a slope of 1/2 and a y-intercept of what? Is everybody up here looking? What's the y-intercept right here? 3. So this really reads y equals 1/2 x plus 3. Hopefully by now, by this point in your life, you're graphing these as second nature, right? Up 3, put a dot. Up 1 over 2, up 1 over 2, put a dot. Okay? Then you draw a line through the two dots. Like that. Okay? So if I draw a line through those two dots, it looks something like that. Now, how do we graph this one down here on the bottom? Go down how many? Is everybody watching so you can do this if you have to? Down -6. Slope is rise 2, run 1, because you have to put a 1 under this, you got slope. Rise 2, run 1, and then draw a line through those two dots. And notice they're symmetrical about this y equals x. Like if you flip this one over, you like flip it over like that, they'd be symmetrical about that line. So what's the first step we always do? Change everything. Very good. Change the f of x to a y. So y equals 2x plus 3. So that's number 1. What's number 2? Switch x and y's. So now it's x equals 2y plus 3. Solve for y. Number 3, solve for y. So we're going to solve for y. What does that mean we have to do? -3 from both sides. Okay? And then the very last thing to do to solve this, divide by 2. Divide by 2. So your formula then, right, would be x minus 3 over 2 equals y. Okay. Now, you have to graph that. You have to graph it. You can start with, let's say I had to graph both of them. So you're graphing this, up 3, put a dot. Rise 2, run 1, put a dot. And then just draw a line through that dot. Those two dots. Rise 3, and then slope is 2 over 1. This one here, you need to like kind of split it into common denominators. So it reads, it would be the same thing as x over 2 and -3 over 2. Y equals that. Down 3 halves, if you're going down 3 halves, that's the same thing as going down 1 1/2. It's going to be about right in there somewhere. Did everybody see that? Be about right there. And then I'm going to rise 1, run 2. Rise 1, run 2. And then you draw a line through those two dots. So if I can get this straight, well, pretend like that's straight.
So they're not going to...
Okay, and if you drew a line right down through the middle, see if you drew a line right down through the middle, it would go right through that cross. Right? It would cross right through there. If you did the y equals, that's y equals x. Okay? Yeah, you don't have to write that one. Okay, so here's the composition. If we're going to compose one into the other, watch what's going to happen. I'm going to take, and it doesn't matter if I'm going to start with G and plug into F. So if I take all the G stuff, plug it into the F stuff, it's going to turn into this. You guys remember this from our assignment that we just did? And then I just plug in 1/2 x plus 1, so I plug all that into x minus 2. Now, the distributive property says that if you take 2 and times it to 1/2, you just get 1. And that's going to be 1 times x. And then 2 times 1 is 2, and then minus 2, and there you go. If you cross off the 2's, you end up with just 1x or x. So are these inverse of each other? Yes, because you ended up with the identity. You ended up with x. Now watch what happens if I do the other way. If I plug the f function into the g function. What are you thinking already? If you know this gave me x, what do you think is going to happen if I do it the other way? It's going to get the same thing. You're going to get x because they're inverse of each other. So I'm going to do it the reverse way. I'm going to take this function right here, and I'm going to plug it into that x right there. And so it will look like this. 1/2, here's where my x was, plus 1. I'm going to plug in 2x minus 2 and do the distributive property. So, what is 1/2 of 2? If I do 1/2 of 2, I get 1x. 1/2 of 2 again. -1 plus 1. See what's going to happen? The -1 and the 1 are going to cross off, and you just get x. So are they inverse of each other? Yes. Everybody see that? If you can do that and you get x, you'll know they're
Is there ever a time when we can't plug it in, we have to do that?
You can always plug them in. If you get two functions and they're asking you if they're inverse, you can always plug one into the other. Or you can do it like this too. I can take this right here, and I can switch places. So make this into x. And remember, this is a y right here. This is y. Switch places, and then I can just solve that for y. And if you solve it for y, you will end up with adding 2 to the other side. So I add 2 to both sides. That's going to give me a 2y, and then I divide by 2. Alright? So notice you get x plus 2 over 2 equals y. Now look what the other function is. So you got x plus 2 over 2. Look at this function. 1/2 x plus 1. They're not the same. Why aren't they the same? Yeah, I haven't done common denominator. So if I split it to common denominators, then what happens right here? There's your 1/2, and what's that going to turn into? So it does turn into 1/2 x plus 1, just like that one did up there. See? 1/2 x plus 1. So it does turn into it. And that, we already knew that it had to somehow, because we knew they were inverse of each other. Did you find it?
Yeah.